approximating the area from a graph. This example asks us to approximate the area of the region bounded by the graph and by the x-axis. So essentially we're looking at this green area in here, you can see from the figure, by dividing the interval from 0 to 6 into n equals 3 subintervals. Use a left, right, and midpoint Riemann sum to obtain 3 different approximations. Okay, well, a Riemann sum is a fancy way of saying we're adding rectangles, so don't let that fancy word throw you off. Okay, so let's take a look here. Well, we're dividing the interval from 0 to 6 down here on the x-axis into 3 subintervals, so you can probably very clearly see that each one of these will be of length 2, each one of these subintervals. But just in case that's not clear, we could use this calculation for delta x equals b minus a over n. It's good to see this anyway because we'll keep using it. Okay, well, in this case, b and a are the endpoints, and n is the number of rectangles. Well, b is 6 minus a is 0, all over n equals 3, so that gives a delta x of 2. Okay, let's do the left approximation first. Okay, so for left, right, we go down to our rectangles here, and what this means is, so let's look at this first interval here from 0 to 2. Now we could use a left approximation where we obtain our height from the left side of the rectangle, which would give us this small little rectangle here. If we were to use the right, which we'll do next, we'd just take the same base, but then we'd use the right side to get the height, and look, that gives us this huge rectangle. So it really matters if you choose left or right. So let's do it with left first. So let's see here. So we have these 3 rectangles. So our area is going to be, our total area is A1 plus A2 plus A3 for these 3 rectangles. And let's draw them in. I'm going to draw them in red here. Okay, so A1, we're using the left endpoints here. Go up to there. And then for the second interval, I'm using the left endpoint, so I go up to here to about 6, it looks like. And across here, boy, I can't draw a straight line for the life of me. And down. Okay, and now for the third interval, we're starting at 4. We're going to go up to the left endpoint all the way up here. Looks like to 9, and across, and that makes our rectangle. Okay, there we go. So A1, A2, and A3. Okay, well, the area of a rectangle is base times height. The base of A1 down here is 2 times the height of A1, which is 1. Okay, on to A2, so plus the base of A2, which is 2, times the height of A2, which is 6, plus the base of A3, which is 2, times the height of A3, which is 9. There we go. Okay, so this gives us, what is that, 14 plus 18, 32. And note that this is an underestimate, right? We're just taking these 3 areas, and note that it's going to come in less than the total green area under the curve. So this is an underestimate. Let's look at the right endpoints. And this is called a right Riemann sum that we're about to do. This thing we did up above was called a left Riemann sum. Okay, so let's draw in our rectangles with right endpoints now. So we still have our same base for all 3 of these. 0 to 2, 2 to 4, and 4 to 6. But now we're using the right endpoint, so I'm going to go over to 2 here and get my height this way. Okay, and then that brings us up to 6 for that first rectangle. Okay, and the second one, I'm going to go over to 4. That takes us all the way up to 9, it looks like. Kind of nice how they come out on these whole numbers. That makes our second rectangle. Okay. And then for our third rectangle, we go all the way out to 6. And that brings us up to 11. And down to complete our 3 rectangles. Okay, so now we have A1, A2, and A3. So the total area again is the sum of those 3. Okay, go back to our old school geometry here. Base times height. The base is 2 times a height, in this case of 6. for A1 plus A2, the base is still 2, and now the height is 9, plus A3, the base is still 2, but now the height is 11. Okay, so 12 plus 18 plus 22 equals 52. Okay, well this number is far different from the left Riemann sum, but of course it is, because now we have an overestimate, because look at these rectangles. They're all overshooting the area. They're going above the graph. So here we have an overestimate. And again, this was a right Riemann sum. Okay, finally, let's do an estimation using midpoints rather than these left or right endpoints of our intervals. And I'm thinking this will give us a much better estimation. Here we go. We still have our three intervals, so 0 to 2, 2 to 4, and 4 to 6. But now we do the midpoint. So instead of choosing 0 or 2 on the first rectangle, I'm going to choose 1 to get my height. That takes us up to 4. So you choose the point on the x-axis halfway between the two endpoints of your interval, and then use that to gauge the height. Okay, so we chose 1 here, and now between 2 and 4 we'll choose 3. Use that to get the height. We get 7. Draw in that rectangle. So a lot of drawing. It's kind of nice, right? It reminds me of, I don't know, some time past when we could sit in math classes and draw shapes and estimate areas. Okay, the last interval here, between 4 and 6 we have 5. Up to the top here we get up to 10. There we go. There's a rectangle. All right, something like this. Right. Okay. Well, that's just getting worse, but you get the idea. A1 plus A2 plus A3. A1, A2, A3. Let's get our total for the midpoint approximation of these three rectangles. Here we go. A total is, all right, our base is still the same, 2 times the height of A1, 4. Plus the base is still the same, 2 times the height of A2, 7. Plus, of course, the base is still 2, and the height is 10 for A3. And you could even factor that base out. In fact, that's what we end up doing on a lot of these. You can just factor that 2 out to the beginning and just add the heights and multiply once. That's faster. In fact, let's do it. 2 times the quantity 4 plus 7 plus 6. That'll save you some time. Plus 10. That'll save you some time. Okay, 2 times 21, which is 42. Now, I don't know if this 42 is an overestimate or an underestimate, but I know it's better than our left and right Riemann sums. Just visually, we can determine that. So it's a pretty good estimate. And if we use trapezoids or something like that, it would be even better, right? Look at this. We could use trapezoids here, these weird trapezoidal shapes. We'll do this. You do this actually in Calc 2. You do some estimations using trapezoids. But you can imagine there's all these ways to get better and better approximations. And of course, what we want to do is take an infinite number of infinitely small rectangles and get an exact area under the curve. That's where we're headed.